So yeah, to reiterate, assignment 1 is due September, not October. The end of September, not the end of October. The end of October is obviously, it should be obviously not correct. But I will send an email out to, actually, can someone do me a huge favor and send me an email? I need one volunteer. Okay, you. Send me an email saying, email the class. Okay. If I don't email the class, it's his fault. Because he didn't remind me. All right. All right. Another thing I want to make sure is made clear to you. And often this can happen in like high school because you have bad high school teachers or whatever. When I ask you to do something for a lab, when I ask you to do a lecture activity, when I ask you to do an assignment or something, the point is not for you to tell me the answer. Okay, that's not the point. I don't need you to tell me what the density of Starbucks is around Halifax. I don't need you to tell me that. I really don't. Okay? The point is not the answer. The point of you doing these things is you getting to the answer. That's the point. Okay? It's not the destination, it's the journey. Okay? We start here. You need to get here. This is what matters, this part. Obviously, you want the right answer. Yeah, obviously. But this is what's important. Telling me this doesn't do me any good and it ain't you doing you any good. This is the point. Okay? And remember, you're going to be wrong a lot. If you magically are getting the right answer every time, good for you. But getting it wrong once and like finding a solution somewhere or something, that's not doing you any good. It's all of the meandering and mistakes you make along the way and figuring out what worked and what didn't work. Really, that's your learning. Me showing you the right way to do assignment 1 doesn't do you any good. Me showing you the right way to do lab 2 doesn't do you any good. This is what it's all about. All right? All right. Any questions or anything before we really get going? Because that was a very good question. Yes?
How professional do you want this email to be?
You could be like, send email, and that's good. All right, cool. I mean, super professional. Make it as super professional as you could possibly imagine. All right. This is where we left off last time. This concatenate strings and then like crisscross concatenation. And I was warning you that this was like your first tricky problem. There's been tricky things we've seen before, but a lot of those tricky things have been like, careful, return and print are different, where this is more of like programmatical, like algorithmically what you're thinking. And the whole trick to this one, I mean, here's a working solution. The whole trick to this is that this function calls that function that does something for us. Okay? That was the trick. You can write functions that call other functions that call other functions that call other functions forever. You could do that if you wanted. And that's maybe fine for what you need to do. If this makes perfect sense to you, good, but be realistic. Don't be like, yeah, okay, I see it, it makes sense. No, make sure you understand it. And there are videos here that cover these two things, all right? So if you're not quite sure, watch the videos. They cover it for you because this is a big deal one, all right? These are older videos and it's Python 2. The only difference you're going to notice is the prints won't have the parentheses. That's fine. What I mean by that is I showed you this before, but I'll show you again. In Python 2, you could say like print hello and it would work. And in the version of Python that we're using, this won't work anymore. It's saying like, well, you're missing your parentheses. So yeah, add your parentheses. Cool. All right. Composition. Like in the crisscross concatenation function that makes use of concatenate strings, okay. we can compose functions. Because remember, when a function returns something, that function like effectively evaluates to the value that's returned. In the same way that 1 plus 1 evaluates to 2, a function that does some calculation and evaluates to 2 and returns 2, that function call turns into a 2. Like I could do this. I could write this line of code, square of sum 2, 2, square of sum 3, 3. We wrote this function before, but long story short, it squares the sum of these things. So 2 plus 2 is 4 squared, 16. Like this evaluates to 16. This evaluates to 36, which evaluates to 52. So not only do variables store values, because functions return values, they can be used similarly, okay? You could even nest these things, and we've been doing this a bunch. How many times have you done, like, I like to do it like this, right, where I do, right? I like to do it like this, okay? But how many of you have been doing this? And you're like, I don't want result. I just want to do that. How many of you have been doing it like that? And if you have, entirely fine. That's fine. You could do that. And this works because this is a function call. It goes, does its thing, and it comes back with the string. In this case, it would be like 1, 3, 2, 4, right? So this whole thing evaluates to 1, 3, 2, 4, which then gets printed out. So you can do that, and it's just fine. And that's what I'm showing you here, right? I can do square of sum with the argument, oh, it's a function call. That function, square of sum 2, 2, would go evaluate. That would turn into 16, comma, this will evaluate to 36, which means we are effectively calling square of sum 1636, which gives us 2,704. Do you see? If you like this, great. If you're like, I don't like that, I don't really like it either, I would recommend doing like call it, save it to a variable. Call it, save it to a variable, pass it as arguments. I like my code to do like one thing at a time. Nesting things like this can get kind of harder to follow. And remember, good code is usually just like easy to read. Code is not for computers, it's for humans. So yeah, it would be a good exercise to work this out by hand. But remember, this is a function call that gets evaluated to something. And by the way, this is not like on the test. This is not overly important for you. You would look at this and be like, okay, so there's two function calls here. This is just trivia for you right now. There's two function calls. Really, there's three. There's this one, and this one. I obviously can't run this one until I know what this evaluates to and what this evaluates to, right? Right? If that's not clear, square of sum needs two integers, or two numbers, okay? I gave it two function calls. Well, no, those function calls will evaluate to a number, because they get returned, which will then just immediately get passed on as arguments, okay? So there are three function calls. This one here, it's three function calls to the same function, which we can do. That's entirely fine. This one right here obviously isn't going to be the first one that runs, because I need to know the answer to these before I can call this one, right? I need to know that this is 16 and that is 36 before I can call it. Do we agree? Okay. Now your computer is only going to do one thing at a time. And we have two function calls here. One of them is going to get run first. Just as trivia, Python will evaluate them that way. So this will actually be the first one that runs, and we'll get 36, and then that turns into 16, and so on, which is kind of neat, but not overly important. To spell it out a little more, it would actually kind of, I mean, really, if I wanted to do it, it would be like this. That would be like the steps, if you really cared, because it can't evaluate both at the same time in parallel. It would have to do one at a time. So that's why it would go that way. Again, not on the test, not really overly important, but kind of neat nonetheless. All right, cool. If this confuses you, You're trying to think too hard. Don't skip any steps. When in doubt, what does the code say? And as long as you can follow where the code goes, you can find out what the code says. Okay? When in doubt, what does the code say? If I gave you like a question like this on the test, where like I'm nesting things or something like that, no human would be like, oh, that's 2,700. No, you'd have to go and like trace it out. And if you're like, this is still so wild, I almost guarantee you in math class have done something like this with functions, but you're using this syntax. I can guarantee you've done stuff like this before, where you've like had function calls nested and whatnot. Don't think because it's code it's any different. The code is just math. We're using different symbols. All right. If you get confused, yeah, just work through, slow down. There's one trick, follow the code. Functions get evaluated and turned into values that get returned. Find a function you can evaluate and evaluate. Cross out the function, replace it with the return value, keep going. Kind of like what I did here. Okay? Now as a quick exercise, solve this one. Do this one. No computers, pencil, paper. Go. You're not handing this one in. You can use a computer if you just want to type or whatever. I just mean don't run the Python code to get the answer. But evaluate that one by hand, okay? Here, I'm going to... There. There, I put it here and made it bigger so it might be easier to follow like this. What's up? By all means. You should make some closer friends so you don't have to walk as far. If you're not, like, you could go back and evaluate everything if you go look at the square of some function and be like, okay, every freaking step. Think about it at the more abstract level of what does that function do? What I mean is this is the square of the sum. Okay, 0 plus 1 is 1, 1 squared is 1. Like, I don't need to actually go look at this code if I know what that code does. I can interface with that function at the level of what it does. Obviously, it does the addition and square it, but I can like do that. Okay, so I'm just going to work through it now. So square of sum 0, 1 evaluates to 1. Why? Well, 0 plus 1 is 1, 1 squared is 1. Okay? And then this here, Well, square of sum 1, 1, 1 plus 1 is 2, 2 squared is 4, right? Well, that's 5, so I can replace all that with 5. And then square, well, I just cut, that's 4, right? Now 4 plus 9, what's 9 squared? Pardon?
81.
So is the answer 81? Yeah? Awesome. There. So like that's what I mean. What does the code say? If I really wanted, I could have gone and been like, okay, def, okay, what was the function? A, B, the sum equals A plus B, the equals the sum, that's, I don't know where that E came from, times the sum. Like you could go and be like, okay, 0, 1, okay, 0, 1, 0, 1, 1, stay there. Blah, blah. You could do it like that, but I'm going to operate at a higher level of abstraction. I'm going to operate at the function level because I'm comfortable with it. Okay? All right. All right. Variable scope. We already kind of talked about this, but I'll show you real quick. Maybe we only talked about it in lab. This won't work. Okay? What am I trying to do? This is just the Celsius to Fahrenheit question, okay? I call the function Celsius to Fahrenheit 32. That means this code runs. That means partial conversion gets assigned whatever that is. And partial conversion plus 32 will get assigned to whatever that is. Then I return temp in Fahrenheit. I'm not actually doing anything with it. But that's fine because down here I'm printing out temp in Fahrenheit, which should have been storing the value I cared about. I mean, that's the value I'm returning. So, I mean, effectively this will be the same, whatever. I'll just print it out. That won't work. This is because of what we call scope. Every variable that you define inside of a function only exists inside that function, and that's a good thing. We like it like that. It might not be obvious at this stage, but if you're like, that's annoying, you're wrong. It's wonderful. But you will eventually see why that's awesome. Point is, it's saying, I don't know what that is. And you go like, it's right there. And I say, it only existed inside that function. When you hit return, this function stops executing and it returns to the line of code that called it, which in this case it would be 6. Everything inside that function is obliterated. It's gone. The computer, it's gone. It's forgotten about it. That's why return is so important. It's how you get information out of the function. We want our functions to be these pure, isolated things that do their thing. I don't want to get anything. No, it just operates the way it's supposed to. We can't access that stuff. Now, you can kind of go the other way, where like, what if something's defined outside? Can you use it inside? And there are like ways to do that. Don't do it either. You don't want to do that. That can be a problem. Exceptions would be things like constants, for example, but in general, you don't want to be doing that too much. Anyways, yes?
Sorry, wait, you said don't use stuff from outside of a function inside of a
Yeah, so like let's say I were to be like, so like a equals 5. And then here I'd be like, oh, return that plus a. Nope. So like that's not going to, oh, right, it's unhappy there. Right, that'll work because like, well, A's here and this will know about it, but this is kind of like a recipe for disaster. Exceptions could be things like your constants, right? Where you're like, okay, this is some constant value, like pi, for example, right? Like, okay, pi is pi.
Right, okay.
But in general, you kind of don't want to do it. So this can see this way, but we definitely can't see that way. What else to say about this? Also, be aware, like, these functions can be called whatever we want. right? It'll work. Well, let me get rid of this nonsense. Like this will work. Now that is a bad, that is a very bad function name, right? But like you wouldn't want to call it that, but you could call it that. The only, like one rule though is you can't use keywords and you can't start with a number just based on how Python parses the code. But you can have numbers inside. Whoops. But again, not a particularly good function name, but it could work. I emphasize this because some people are like, so it has to be called temp and no, you can call it whatever you want, but that is a good name for the function. All right. Okay, that's whatever. No, there's a way to also have global scope. If you really wanted something within a function to be accessible outside, there are some keywords you could use to like force it to. Don't do it. That's, you don't want to do it. And there's like this concept of like stinky code where like that would be an example of stinky code. If your code is doing things like that, in and of itself, it's not a problem. Like a stink isn't the problem, the source of the stink is the problem. So like if you have to write code that your code is stinky, you probably have an underlying issue that needs to be solved. So that would be like a stinky problem, by the way. All right, and then there's imports. We talked about this already, right? Python has a bunch of built-in functions for us. And here's Python standard library. Has a bunch of built-in Pythons for us, a bunch of stuff you would never want to write. Who wants to write the code to calculate sine? I don't. Good news is Python gives it to you for free, but unlike a lot of functions like print that when you load up Python for the first time, print's there because you're always going to be using print. But you might not be using sine a lot, but when you need it, you want it to be there. So instead of wasting time and energy of loading all of these functions into the computer, which takes time and energy, it will load up, Python loads up a minimal set of functions when you load up Python. And then if you really want the math stuff, you would write that like import math, okay? That's how you would do it. And here's an example of like the math library. This is where all like the mathy stuff is. And if you say like, well, who decided that like all of these functions belong in the math library? It's probably Guido. Yeah.
When you import math, is it all the math?
It will. And there is a way to say only import something in particular. And there's a couple ways of doing it. So like if I go down here, do I have the, okay, I don't have the example here. But let's say I do like import math, okay? And I say like print math.sine of 9. Now mind you, by the way, I'll say this first. Be very careful. Listen to what I'm saying right now. Everyone pay attention, because who here wants to complete assignment 1? That's what I thought. Read the docs. I warn you of this in the assignment 2, but most people don't even read the assignment. Read the docs. Return the sine of x radians. That's not degrees. Uh-oh. If only there's like a good way to convert radians to, oh, there is, don't worry. In the math library, there exists a function that convert angle from x radians to degrees. Oh, that's perfect. Okay, great. Or if I have degrees to radians, oh, fantastic. So be wary. Now, if you're someone who's reasonably normal, you might say, man, like, why does it like radians? Why is radians the default? Shouldn't degrees be the default? No. Because radians actually has some like interesting relationship about something that's fundamentally true. Like it's the relationship of like the radius and like the length of the curves and whatnot, right? So like there's something, it's tied to something like real, where why are there 60 degrees in a, or like why are there 360 degrees in a circle? Because of the Babylonians, because they said so, right? And who put them in charge? You know what I mean? It's ultimately kind of arbitrary, right? They loved the number 60. It's 60. It's all about 60, okay? So in the same way that like, hey, how many minutes are in a second? Or minutes are in an hour? Blame the Babylonians. How many seconds in a minute? Blame the Babylonians, right? So like, why does the computer like it? Because radians actually make sense. Where degrees, yeah, I know that's probably, like raise your hand that when you first started learning about like angles, it was all degrees. Blame the Babylonians. Like, isn't it wild that like we do this way because of the Babylonians? It's weird, right? You want to know something crazy? The size of the space shuttle was constrained by the placement of rocks in ancient Rome. That's true, by the way. Because they had like these rock placements, and so people had to have like their carts with the wheels wide enough to fit through these things. And that became kind of like the default length of like the wheel base. And then also for like trains, and then trains going through mountains, and the space shuttle bits couldn't be too big. They wouldn't fit through the tunnels for the train tunnels. And then next thing you know, oh my gosh, that actually mattered. The placement of these rocks in Rome. Isn't that crazy? Right? How many things in our world is just like and like you figure like there were probably a bunch of dudes in ancient Babylon that were like 60. And here we are. Isn't that weird? Anyways. So why is it radians? Because radians actually kind of, we can point to like, well, it's the ratio of, of these different things where degrees are just like, if we go back in time, would they have done 60 or maybe they would have done 62? I don't know, right? Or 360, you know what I mean? Anyways, so there you go. So back to this. This is how you would call it. And I like this syntax because it tells you, and I like this because I've been burned by this before. This tells you from the math library called the sine function, right? But this will load up the whole library. There's another way to load up the whole library. You could say from math import star. Star means everything. And if you do that, that's kind of like you've like copy and pasted the code in the math library into your code, meaning you don't actually need the math dot out front. This will also work, but then you lose sight of like, where did that come from? Right? Which is fine. And if you really only want one thing, you could do this. Like there. And if I try to do cos, okay, cos is going to work because I probably loaded it up already. But yeah, anyways, point being, you can be very precise. Who asked, does it only load up? Who was it that asked that? Someone asked a question. It was you? Yeah. So, yeah. Okay. And then comments. You may have seen examples of comments in code already. Comments are an interesting thing. Comments are lines of code that aren't code. The computer will not run it. It'll see this line and be like, skip. Okay? That is for a human to read. All right? Now, where do you write comments? There's a couple of places you write comments. If you've got a chunk of code that's rather complex, you might need to explain it. But comments are a funny thing because we really do want our code to be written so well that it doesn't need any comments. Okay? So if your code is littered with comments, that could be a stinky problem. That means your code maybe ain't great. Maybe it works, but maybe it's like low quality code. So if your code needs a lot of explanation, your code might be hard to follow. Maybe you can fix that with better variable names, maybe better function names. I don't know. That doesn't mean don't write comments. Comments are great if you need them, but you kind of don't want to have to need comments. Okay? Sometimes though, at the end of the day, you need a comment. The exception to this is though what we call doc strings. Doc strings, listen to me. If you don't write your doc strings, you're going to get nailed on the assignments. On tests, don't worry about writing doc strings. Doc strings are special comments that have very special meaning. You write your doc strings like this. Every function you're ever going to write better have a doc string. It's where you explain what the function does. So here's an example. Def Celsius to Fahrenheit, blah, 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 colon, indent, and it's here within the function that we start to write the docstring. And this syntax is important. We do quote, quote, quote. 4 quotes. 4, 3. By the way, you can also do block comments like that where you can have like multiple lines of comments between those, but this is like docstrings. We're talking docstrings. I say, what does this function do? Convert a temperature from Celsius units to Fahrenheit units. Great. Then we do like colon, param. This is where we list all the parameters. We do one at a time though. So colon, param, temp, and Celsius. And we explain, what is that parameter? If there was another one, I would say colon, param, some other parameter, colon, explain what it does. And then at the end, we have like colon, return, close colon, the temperature in Fahrenheit. It explains what the function does and how one would use it, okay? And what's neat about this is, now I don't think I can do this in Colab. I can't. But see how like I just hovered over that line right there, and Colab had this pop-up where it's like, oh, return the sign of x measured in radians, okay? If I go, and I can't do it right here. In other environments, I'd be able to do this, but I can't do it right now. If I were to go and actually look up, because all these functions that Python gives you for free, the code to those functions exist. If you download Python on your computer, the code to Python sign is going to be on your computer. If you go and look at that function, you're going to see the docstring that says return the sign of x. This is actually bad because it doesn't say like param and return whatever, right? But the docstrings will act like these types of things are what actually, like see this website here, if I go to the math module here, a lot of languages will work like this. Like if I do POW, okay? See this right here? See that? If I go look at the code, that's the docstring. This website is generated from the code. People wrote their code, put their docstrings, and at the end they said generate the docs. And it just basically took all the docstrings from all the functions and said, here's how you use it. There's the documentation. So the syntax for the docstrings are very important. So where I just said you want to write your code such that you don't need to write comments, that's true. But always write your docstrings. Always, 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 always write your docstrings, okay? Okay. So there's the comments, docstrings, yeah. All right, cool. Any other questions about that? And like, well, why do you write this type of stuff? Because you're going to forget what the code does. And you don't write code for yourself, you write it for other people as well, right? The code needs to be easy to understand. And the number of times you're like, well, this is obvious. I'm going to know what it is. And then you show up a week later and you're like, crap, I can't even understand my own code. It happens a lot. What's this? What do I link? Oh, some stupid meme. All right, great. And what's this one? Yeah, another one. These are jokes that are like, write your comments. Anyways, cool. Any other questions about functions? That was a big topic, but I hope we got it. Someone came to office hours today and asked a great question. They're like, you know, it makes sense when you're doing it, but like when I sit down to do it, it's kind of tough. This is the start of week 3, okay? Don't worry. If people around you are writing code like crazy, they might have a bunch of experience already writing code. So don't compare yourself to them. I'm not teaching to them right now, I'm teaching to you. You are my target. But the only way to get better is by doing. Practice, do, labs, caddis. The exercises, like in chapter 5. Read through chapter 5, that's great, you'll be a pro, everything functions. And then you go down here, there's a bunch of exercises. You do those, you're gonna be really good at this, okay? Practice, that's the only way to get it. Like I said, you could watch literally every video on YouTube about how to play piano, and if I sit you in front of a piano after that, you're not gonna be able to play piano. You have to actually do it to do it. All right, cool. Any other questions? So now I'm gonna teach you something you already all know. I'm just going to present it in a formal way that might feel like pedantic or something, but it's important. Propositional logic. Sometimes things are true and sometimes they're false, right? True. Now, this course focuses on introductory computer science. True. This topic is titled Not Logic. False. Because it's titled Propositional Logic, right? These are true or false statements. It's rather intuitive because you kind of like use this in your everyday life. And additionally, we have some operators, and I'm using the word operator in the same way that I use the word operator to describe like addition. We use operators on this logic all the time, like and, or, and not. For example, here, let's generate a truth. No, let's start with an example. If I were to say to you, am I wearing a hat? Who said no? Because I want you to leave. The answer is false, obviously. Am I wearing shoes? True. Right? See what I mean? Am I wearing a hat or shoes? True. You already know what's going on. Am I not wearing a hat? True. Because you say like, is he wearing a hat? False. Not false is true, right? Am I wearing a shirt and shoes? Am I wearing a hat and shoes? Right? The only one that can get funny is or, because English actually has like a limitation with or, where if I were to say like, am I wearing a shirt or shoes? What do you think the answer is? The answer is true, where some people might be like, well, you're doing both. That's kind of, that would be called exclusive or. That's a whole other thing. But these are your basic operators, and, or, and not. And or are what we call binary operators because they apply to two operands. Now, like addition, that takes two operands, but those are numbers. These are Boolean operators. They work on Booleans and give you back a Boolean. Addition works on like integers and gives you back an integer, right? This is what we call a truth table, where you exhaust every possible combination. So I have the A and B. True, true, false, false, true, false, true, false. So I have all possible configurations of these two things. If I have true and true, it's true. True and false, it's false. False and true, it's false. False and false, it's false. A or B, well now we get true and true, true. True and false, true. False, true, true. False, false, false. That would be like saying like, am I wearing a hat or a watch? No. And then not A, this not only works, it's a unary operator. It only applies to like one value, kind of like negation. Like what's not true? False. It just flips it. Okay? That's it. That's it. You are already all pros of this. So, is the sky blue and is water wet? True. Now, try to make sure you realize, though, that these are statements that in and of themselves evaluate to true or false. True doesn't apply to this statement. It applies to what that statement like evaluates to. Meaning, is the sky blue? True. Is water wet? True. True and true, true. Okay? You kind of have to make that other step. We don't often do that because humans, we operate at a higher level of abstraction. We kind of skip that step, but it is ultimately there. Is the sky blue and is it over 100 degrees Celsius outside? False. Is the sky blue or is it over 100 degrees Celsius outside? True. Is it not over 100 degrees Celsius outside? True. Is the sky blue and is it not over 100 degrees Celsius outside? True. We could start to combine these operators however we want. You will observe that for and, both statements must be true to produce true, otherwise it's false. For or, if either of them are true, it returns true, otherwise it's false. And not just flips it. Or, okay, both statements being true produces true for or, but some people might get mixed up with something called exclusive or, which is only one can be true. That's not what we're talking about. So yeah, people will find or ambiguous at first, but when we're talking propositional logic, this is the definition of or. Okay? It's an exhaustive definition. These are all the possible inputs to or. Okay? Booleans are a type that exists inside the computer. We've seen it already. A type, just like integers, strings, floats, it's a type. Like none type is a type. But unlike integers that could take on an infinite number of values in principle, or in theory, Booleans can only ever be true or false. It's a type, but the values they can take on is only one of two values, which is interesting. And we have Boolean operators and or and not. They are operators that apply to Booleans and give you a Boolean. It applies to true, false, and gives you back true, false. And it works the same way as like addition. But we also have comparison operators, and these ones are interesting because comparison operators will work on things like integers, for example, and give you a Boolean. So addition, integer, integer, gives you an integer. Boolean operators, Boolean, Boolean, gives you a Boolean. Comparison operators are interesting. They will take things like integers and give you back a Boolean. So we're like mixing types, kind of. And what do I mean by that? Well, it turns out you're already familiar with this. Is 5 greater than 3? True. No? You were like, oh, no, it's not, yeah. Is 5 greater than 3? That's a comparison operator. I think I learned this in grade 1. Maybe grade 3. We learned it with little Pac-Mans. Other students, they say, we learned it with crocodiles. Cool. Anyone learn it with Pac-Mans? Who did it with crocodiles? Pac-Man's better, though. Come on. Right? That's a comparison operator. You're comparing two integers, and that statement is either true or false. So this is an operator that is comparing integers. Here's one. 1 greater than 7. That's a false statement. That operation evaluates to false. Here are your common operators. Equal. Mind you, this is equals equals. Remember, single equals is an assignment operator. Entirely different meaning. Equals equals is a comparison operator that will tell you if two things are equal. So if I do like print 3 equals 6, what do you think it's going to say? False. Why? Because 3 doesn't equal 6. But does 3 equal 3? True, right? Now you might say, well, what's the point of something like that? Well, remember, I can have something like this. Right? Where I could be like, oh, no, stop. If I do 2, it should be false. If I type in 3, it should be true, right? So like, don't think it's always going to be comparing literals or something. Well, no, these are like variable values that can be compared. So we have equals. We have not equals, exclamation point equals, which you could also do by saying like, I'm just going to like hard code this to be like 3. Does 3 not equal 3? No. False, right? Right? Whoop. 3 does equal 3. You could also like flip it by just nodding the whole thing. That would work as well, but whatever. You check if they're equal and then just flip it. That would be the same thing as not equals. Anyways. We have greater than or equal to. Why is this important? Well, I could say, is 5 greater than 5? No, it's not. Is 5 greater than or equal to 5? Yes. In fact, even notice the language I'm using. I'm saying or. It's actually checking, like ultimately it's saying, is it greater than 5 or is it equal to 5, right? It's kind of like doing 2 checks at once, anyways. And then we have less than and less than or equal to, okay? We'll skip this. Okay, mind the use of the two equal signs for checking equality. Remember, a single equal sign is the assignment operator. Some variable equals 5 assigns the value 5 to the variable some variable, where some variable equals 5 checks if the value stored in some variable is equal to 5. Two entirely different meanings. In Python, this isn't so bad, but in other languages, mixing these up can have catastrophic problems. Very bad problems. Let me do a quick check, actually. Print A equals 5? No. B equals A equals 5? Why is it not? Yeah, okay. Yeah, this could have bad problems, but we're not going to go there right now. That's outside the scope of this course. And like everything that you've been doing with algebra, where you've got additions, multiplications, and all those things where you've got a bunch of them composed to make big expressions that need evaluating, we can do the same thing with these operators, okay? Now there is an order of operations. Here it is. Don't worry, it's fairly intuitive. You don't need to go through this and memorize this, but there is an order of operations. Like exponent comes before like plus and minus, or comes after, comes before, right? And but plus minus comes after addition, and blah 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 blah, right? Booleans will take place after. So if you have like a plus b is greater than 7, it'll do the a plus b first. It won't do like b greater than 7 plus a. There is an order of operations. If you're like me though, and I'm always paranoid and I want to make sure my code is clear, just add parentheses to everything to make sure it's like, do this first and whatnot, okay? There's no harm in that. No one's going to go memorize this table. So don't think of this and be like, I need to go memorize the order of operations. No. And when you're testing your code, if your answers are wildly wrong, maybe your order of operations is a problem, but chances are you're not going to be having too much of a problem. But like, for example, here's an expression, right? This can be evaluated. Okay, 17 plus 2, okay, 19. Or 17 not equal to 18. Okay, was 17 less than 18? Well, that's false. False or 17 not equal to 18? Well, that's true. So false or true, that's true. See, we can evaluate this just like any other algebraic expressions that we've seen in our life since we were this big. Here's one. 101 equals 166 minus 17 less than 47. Okay, well, is 101 equal 100? That's false. And by the okay, we could keep going, but by the way, I can stop here. I know the answer here. Can anyone tell me why I know the answer right here? Exactly. I see false and it's going to be false. Nailed it. Well done. The result of AND can only be true if both are true. So false and I don't care. Let me put it this way. Am I wearing a hat and does it even matter what I say? No. Because am I wearing a hat? No. False. False and anything's going to be false. So because I'm not wearing a hat, it doesn't even matter what the rest of that expression is. It's kind of like multiplying a giant thing by 0. Right? You see like blah, 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 multiplied by 0. Oh, it's 0. It just kind of like obliterates. That's called like, there's a name for that thing. I can't remember. It might literally be like the obliterator, obliteration. But there's like a property. Anyways, we'll pick up here on Thursday or on Friday. And once again, people on Thursday lab, sorry, but you're going to get a sneak peek at Friday's lecture topic. I mean, lucky you, right?